you by thesis123.com. I learn and teach online.
Here's the next question, number 48. A separately excited DC motor runs at 1000 rpm on no load when its armature terminals are connected to a 200 volts DC source, and the rated voltage is applied to the field winding. The armature resistance of this motor is 1 ohm. The no-load armature current is negligible. With the motor developing its full load torque, the armature voltage is set so that the rated speed is 500 rpm. When the load torque is reduced to 50% of the full load value under the same armature voltage conditions, the speed rises to 520 rpm. Neglecting the rotational losses, the full load armature current is dash. Okay, so this is not a multiple choice. So let's begin with writing down what's given to us. So we start with the speed given as 1000 rpm. So let's call that as N1. This is our rated speed, 1000 rpm. Then we have no load EMF, back EMF, we'll call that EB1, 200 volts. And we also have the armature resistance to be 1 ohm, so that's RA 1 ohm. Now the question says that with the motor developing its full load torque, the armature voltage is set so that the rated speed is now 500 rpm. So let's call that N2. This is the second case. So we have N2 at 500 rpm. And the next case says that the torque is reduced to 50%. So when the torque is reduced to 50%, this talks about the torque at N2 is reduced now to 50%. So the relation, we'll call the torque as T2 and T3 for two different cases. Okay. So here, let's say that the torque T3, the subscript over here is 3 because it's being reduced to 50%. It would be 0.5 T2. And then the speed N3 becomes 520 rpm. I hope you're following. I'm using different subscripts, but they indicate two different cases that have been stated in the question here. Okay. So at N2, 500 rpm, torque is T2. Then the torque reduces to 50%, that becomes T3. So T3 is 0.5 T2. And then the speed becomes 520 rpm. So this is all that we have. Now we are supposed to find out what is the current, the armature current. Okay, so let's begin with the general relation. We have a relation for DC motor where the back EMF is directly proportional to the speed. So using this, we can write down a ratio. So let's write down a ratio between EB1, EB2 and N1, N2 so that we can find out what is the back EMF at the speed of 500 rpm. Okay. So this becomes EB1 by EB2 equals N1 by N2. So now let's substitute the values of EB1, N1 and N2 and find out what is the value of EB2. Okay. So I'll just write the expression again. EB1 by EB2 is equal to N1 by N2. Okay, so let's substitute. EB1 is 200 divided by EB2 equals 1000 divided by 500. So if you solve this, EB2 should be 100 volts. Okay, so this is our value of EB2. Now we also have another relation in DC motor which corresponds to the back EMF, the voltage, the armature current and the armature resistance. So I'm sure you're familiar with this. EB is equal to V minus IA RA. This is our EMF equation. So let's use this in terms of the second case, EB2. So now here we would have EB2 is equal to V minus IA2 RA. So let's substitute. We have 100 is equal to, we don't know the value of V, the voltage, minus IA2. This is the armature current that we are supposed to find out at the speed of 500 RPM. RA is 1. So here our equation becomes 100 is equal to V minus IA2. Let's call this equation 1. Okay. So I'll solve the rest of it on the other side over here. Now similarly, exactly what we did in finding out the value of EB2, now let's find out the value of EB3 using the same relation. So here we would have, we can now write this as EB1 divided by EB3 is equal to N1 by N3. Okay, so let's substitute. We would have 200 divided by EB3 is equal to 1000 divided by 520, since that's the speed now. N3 is 520. So EB3, once you cross multiply and solve for EB3, you should get the value as 104 volts. Next step, we do the same as we did earlier. We now take the same equation, EMF equation, substituting the subscript of 3. So we have EB3 is equal to V minus IA3RA. Okay, so when we substitute the value, that's 104 is equal to V minus IA3, since RA is anyway 1. So this is what we have. Now we have 3 unknown variables here. We have V, IA2 and IA3. So the next thing is to try and find out a relation between IA2 and IA3 so that we can find out what is the value of IA2. Now here let's use the torque. Okay, before that let's call this equation 2. Okay, so now let's take the relation between the torque and the current. Now you know for a DC motor that the torque is directly proportional to the current. So using this we can write down a relation as T2 by T3 is equal to IA2 by IA3. Now we know from the question given to us that T3 is 50% of T2. So we can substitute that. Let me just grab another sheet of paper and we'll continue. Okay. Right, so we have now T2 by T3 is equal to IA2 by IA3. Okay, let's substitute. We have T2 divided by 0.5 T2, that's T3, okay, is equal to IA2 by IA3. So now we will have a relation IA3 is equal to 0.5 IA2, right? Or we can even say that this is IA3 is equal to IA2 by 2, since 0.5 is 5 by 10, 1 by 2. Well, you know how it goes. So it's IA3 is equal to IA2 divided by 2. Either way, you can use either one. It's not a big deal. Okay, so now we have the relationship between IA3 and IA2. So let's substitute this, I'll call this equation 3, into our second equation here earlier. So we had 104 is equal to V minus IA3. So let's substitute IA3 there. I'll just write that down here. Okay. So we place, substitute 3 into 2. So we would now have 100. Oh, that's 104. Sorry, my bad. Okay, 104 is equal to V minus IA3. This is our second equation. So now when we substitute, 104 is equal to V minus 0.5 IA2. Let's call this equation 4. Now we have our first equation and the fourth equation in only two variables, two unknown variables, V and IA2. So now solving 1 and 4, I'll leave the solving to you. 100 is equal to V minus IA2, that's equation 1. And then 104 is equal to V minus 0.5 IA2, that's equation 4. Now solving both of these, you obviously know how to do this on a calculator, and you will find the values of V and IA2. So solving, you would have IA2, the answer must match 8 amps. So please work it out and see if your answer matches this. So the final answer here is 8 amps. We'll just mark that in the blank here, 8. So this is the entire solution, and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.